Good morning, everybody. So as usual, this is webinar format. So for people online, hopefully you don't have any technical issues for now. And so if you have any, just put them in the chat. And also don't forget to, for people online, don't forget to put your question in the Q&A tab, because we will open your mics at the end of the seminar for you to be able to ask questions. And now for everybody, we have two announcements. So next week will be the Thaler conference with Joran Almqvist will be there, and also to discuss with students. And I think Philippe is also quite keen on discussing with many people here. And the second announcement is that there is still time to send some propositions for the seminar of the next semester. So don't hesitate, and everybody is encouraged to send their proposals. It can be from permanent researchers, but postdocs and PhDs are very much encouraged to also suggest some people they would like to interact with. With that, I will let Jos introduce today's speaker. Thank you.
Well, thank you, Céline. Thank you, the organizing committee of these seminars. So we have the pleasure to see François Graner today. He is a biophysicist. He did his PhD thesis really on physics at very low temperature. We are sure that nothing else than physics can happen. And then he went to study hydras in Japan for his postdocs, and he got interested in biology, the interface of biology and physics. So just to say also, he's a physicist, but truly interested also in interdisciplinary work. He doesn't think, if I'm correct, that everything should be explained by physics. So he has been interacting with many biologists as well. So during his career, during several projects. And he's also interested in many other things, and that's why I invited him today. And one of the things is what he will be talking about on the role of science in the current system. And with that, well, maybe I'll let you introduce yourself more. It's just two announcements I have to make. We have at 2:30, we have planned also a discussion with PhD students, internship students, postdocs, etc., students in a large sense, and that will be at Systèmes in building 22 of the Triolet campus, where we'll be able to discuss more with François if there is any questions that remain to be debated. So all of you who are in the early stage of their career are invited to join and bring friends, even if they didn't come to the seminar. And also this evening, so François, I have a copy here. François participated as as to advise on this book. It's comic, you call it in English, which is about related to the topics he'll present. And there will be a discussion about this book at the, it will be in French, as the book is in French, at the Librairie Saint-Paul Rue des Soldats in Montpellier at 7 o'clock. So you're invited as well if you want to know more about that, but will be in French. So I've spoken too much. What are yours?
Okay, thank you for the invitation. Thank you for the organization, and thank you to all of you for coming, including for those who are online. So it's a pleasure to be here and to talk about research, growth, and degrowth. So I come from a lab in Paris called the Complex Systems and Matière. And as Jos said, I'm a biophysicist. I even spent 4 years in the developmental biology lab, so I should be able to talk with biologists. And but basically, what I often do since a few years now, I participate a lot in debates which involve both science and society, and obviously that's the subject of today. That's not a talk dedicated to specifically to biology or to evolution or ecology, despite the title of this CFE seminar. I want to, as a preliminary declaration, I want to make clear that I do not commit my supervisors. I do not speak on their behalf. And I try to separate fact and opinion. And of course, it's a difficult exercise. So I ask you for indulgence, to forgive me if I don't always make this limit clear, and you can help me make it clear. I welcome your questions. If something is not clear, if I talk too quickly or with a bad English accent, please interrupt me immediately. Everybody in the room will be pleased because it will help the others. But if you have a question about something that should be debated, really, I think it's better to keep it for the end. I will make my best to leave enough time for questions at the end. Okay? My outline will be as follows. I would like to talk about planetary limits, about the scenarios that we can do within these planetary limits, and what is the role and place of research and scientific research in these scenarios. And I will try to conclude with a take-home message. So first, I would like to present my view of planetary limits from the point of view of biophysics. So, at the basis, at the starting point, there are two principles in physics. They are called conservation of quantity and degradation of quality. I will try to develop that. They apply to matter and to energy, and they are much more commonly known for energy. They have a name, which is the two principles of thermodynamics. And they don't have name when they apply to matter, but they apply to matter as well. And what does it mean? Conservation of quantity and degradation of quality. Well, matter. First, let's talk about matter, conservation of quantity. Roughly, you have almost 100 elements in the Mendeleev table, 92 in practice in nature. And these are conserved. For instance, you have here on the picture, you have the carbon. Carbon is conserved, which means that except for small corrections that I won't discuss here, each atom is conserved, and for billions of years, it's the same atoms that we have in the ecosphere, that is in the thin layer at the surface of the Earth where we are living. Ecosphere, basically, it's the surface of the Earth, of the ground, plus or upper crust, plus lower atmosphere, plus upper ocean. And this region is about conserved, and which means that, so there are a few exceptions. There are a few fluxes in, for instance, due to meteorites, volcanism. There are a few fluxes out because of subduction, but basically you keep the same atoms conserved. So a fixed amount of each element. But the quality of matter can degrade and even spontaneously evolve. The matter can get diluted, can get oxidized, material can be broken, and so on. There is a spontaneous tendency to degradation, and if you can reverse this evolution, but then you need energy because to invert spontaneous transformation, you need to make efforts. And for instance, so this example of a rusted car, but another example is if you dilute something, you take, for instance, syrup or ink, you put it in water, it gets diluted. If you want to make it back and get the ink back, you need to make a lot of efforts and produce and have energy. And what is energy, basically? By the way, energy is what what measures how we act on the world, how we transform the world. That's measured by a quantity called energy, with the unit which is called the joule. And again, we have conservation. That is, energy is not produced, not destroyed; it's just converted. The difference with matter is that in the ecosphere, we have a lot of energy influx. Here we have a huge influx, which is called the solar flux, coming mostly from visible light. We have other fluxes, but they are minor. Geothermy, tides, they provide energy to the ecosphere. But basically, we have solar flux, and it's conserved. That means if you have flux in, you need flux out. and the flux out is that the Earth radiates energy in the universe, in the space, mostly as infrared light. By conservation means there is the same quantity of energy which goes in and which goes out. But the quality of the energy degrades, and you have many forms of energy. And when you convert energy, at the end, it degrades into heat. And well, the Earth radiation as infrared is what we call heat. So whether it's renewable energy from solar flux, solar, wind, hydro, biomass, whatever, or whether it's fossil fuels, coal, oil, gas, at the end, if you use it, it degrades. So, which means whenever we talk about production of matter or energy, it's wrong. We do not produce. Human usage means extraction and conversion. And each time we act on the world by extracting, and converting, we degrade the usability of the energy of all the matter. And this ends up like that, for instance. So automatically we produce more waste. Whatever the definition, there are many definitions of waste. Whatever your definition, we produce waste. And we produce more and more. And there is no way out. There is no outward flux. So waste accumulates in the ocean, in the ground or on the ground, in the atmosphere. And that's, you might have heard about senile squalor syndrome, people who never throw away the garbage of their apartment. And you can imagine that very quickly it's problematic. And so that's what we are doing on our planet, basically. So, in fact, that means that we couple, the human activity couples and makes many feedbacks between matter, energy, and environment. And we have to think very globally in terms of the three. And also we have to think from the local scale to the global scale. So in fact, it's a very complex system and maybe too complex for our brains, at least for mine. For yours, I don't know. But for me, I find it very complex and multi-scale, multi-factor, and difficult to describe. Which means that, and maybe that's one of the most important slides of this. So if you wake up only at one moment during the seminar, maybe it's now. You very often hear about planetary boundaries, but there are three very different definitions, very different. The hard ones are those of the physicist. They are the principles I told you. The matter is limited. The amount of matter in the ecosphere is limited, it's fixed. The amount of energy we can use is, if renewable one is limited by the solar flux. That's what we call the hard limits. That's what you cannot change, cannot negotiate, you cannot discuss in the parliament here, okay? But, and that means that infinite growth of activity is not possible in a finite world, that's true, but it has no practical effects on us. Because the solar flux, for instance, is huge. We have no energy crisis if you think that the solar flux is 1,000 times what we consume. With the total humankind energy consumption, the solar flux is 1,000 times more. So we have no energy crisis. Okay, and well, for matter there are limits. Of course, it's finite. We have but we have plenty of matter for years. What is much more important, practically, is the soft limits. That is the practical constraints linked with technology, economy. Can we harvest this matter? Can we harvest this energy? And these limits are much, much lower. We cannot harvest all the solar flux which arrives. We would need to cover all the Earth with the perfect, ideal solar panels, and we cannot do it because of the matter. And because of the surface, because we have to use surface for other things. So for practical reasons, we cannot capture the solar flux. And all the things that you can think of, they are limited by soft limits. Why soft? Because these can be changed by technology progresses, by discussion, by political choices, whatever. And so these are the limits of the economy, not of the physics. If you think about them, the energy is limited, and you are probably aware of that. And the matter is very limited, and you are probably not aware of that. In fact, almost 80% of the 92 elements are in a critical state. Means that within a few decades, that probably the next generation or the next one will see the end of them, reaching the soft limits. Okay, and that's why I say this is important. And there is much confusion between these hard and soft limits, in fact. And the third one is the one of ecology and evolution. It's the environmental limits. That means that, yes, we can extract more matter, extract more more oil, whatever, but it damages the environment. Climate change, of course, plastic, biodiversity, weather, pollution, all what is called planetary limits for the ecologist. That's here. And these are not hard limits. These are limits that we humans can decide to respect or not. And so that's subject to political choices, as you know. And so the status of this, the limits for the physicist, for the economist, and for the ecologist, the status is very different. Okay? And all of that are planetary limits. Questions about that part? Any question? No? Either you didn't wake up, or it was super clear, or it was not clear at all, and you are lost, whatever. No, yeah.
I had a question about when we talk about degrading matter. Why we talk about degrading? Because there's kind of an idea of value behind this word, but in an objective way. Just
Thanks a lot for this question, which is a clarification question. In fact, on purpose, I didn't enter into that question, but there are two answers in your question. The subjective one and the objective one. The subjective one is the one you can feel, and it's very related to the human usage. And for instance, oil for us, it's a waste of life at the Carboniferous period because there was no recycling by mushrooms and so on. For us, it's not a waste. So obviously, but there is a definition which depends on the species and so. But when you have a rusted car and a new car, for the human usage, obviously one is degraded with respect to the other. So that's the subjective part. The objective part is based on a notion that the physicists like to use but don't like to explain, which is called entropy, which is a quantity that you can measure. And this, for the energy, is very easy. You can see that at each step you use energy, you will degrade. Increase entropy, which is degrade, and heat has a higher entropy than chemical energy, gravitational energy, mechanical energy, whatever. And for matter, it's the dilution or something called the chemical potential, which describes entropy, which tell you that something which is oxidized or diluted has a higher entropy, and so more degraded state than when you have a pure ingot. When you have steel, which is completely pure, or gold, which is completely pure, it has a very low entropy. And when you oxidize, combine it, or dilute it, it's worse. And so it goes with the common sense. Of course, the two definitions goes together, but one is more objective than the other. Does that answer?
Yes.
Thanks.
I missed a point in the slide about fluxes.
Yeah. Matter or energy?
Energy.
Yeah.
Some part of the solar flux is used in photosynthesis, so it is stored. Oh, I missed it.
Okay. The solar flux, this is the point of view when taking the ecosphere as a system, what enters, what goes out. You might say that if some part is stored, at some point it's degraded in a steady state. Of course, the Earth is not, and the ecosphere is not perfectly in steady state, but over 1 billion years, it's more or less steady. There is a huge amount which is going in and a same amount which is going out, and a very tiny part which is stored. For instance, when you have oil, as I said, oil, coal, gas stored in the ground, means that during some time it was not radiated by the Earth. This energy was stored and not. So there are some tiny corrections. All what I say, all the sentences I say can be more or less corrected if you look in detail. But in the broad lines, that the ecosphere is in steady state with in flux and outputs which are equal. But of course, the life and the humankind use this. You can, if there is no life, you just have flux entering and going out. Life captures this flow, and biomass is a way to capture the flow. Hydroelectricity is a way to capture this flow and use it, but still at the end it degrades. When the living system, living organism dies, it will degrade into heat. It will put it. Okay? So, we can, no other questions? Now, scenarios. Well, within these constraints, what are the dominant scenarios for humankind? Well, the one you hear a lot about is growth, which is basically growth of economic activity. The official definition is based on monetary fluxes, which is something very subjective, and which dates from second half of the 20th century and scenario since the 60s. After a lot of discussion, it's not at all something deeply rooted in humankind. It's very recent. For the physicists, we prefer to talk about the growth of the action on the world, means growth of consumption of energy. And also, what is very important is the power. Power means not only how much energy you consume, but how fast you consume it. Because if you consume energy fast, you can do some things that you cannot do if you consume energy slowly. If you want to build the Egyptian pyramids or the Chinese Great Wall, you can do it at low power or at high power, that is with women and men and animals, or with caterpillars. But if you want to have a TGV, a high-speed train or a rocket, you need high power, right? And so power means that for physicists, energy per second, but here again, it's close to the common sense of power, which means the military, economic, political power. And if we have growth of action on the world, we have growth and the consumption of matter and of accumulation of waste. All that is related. That we cannot, the accumulation of waste is directly related with the increase of our action on the world. Okay? And this growth has positive outcomes, which is why it has its proponents. It gives humankind better access to food, to health, to information, globally speaking, and to many other things. But there is a but. And as you know, everything which is before the but is bullshit. So only what is after the but matters. So there are negative outcomes of the growth. And the fact that we currently have a global crisis in terms of energy, materials and environment. The fact that we have many inequalities, whether environmental, political, or social. The fact that wildlife collapses, and that even domestic and human lives, domestic life and animals and plants and human lives are maybe threatened. I mean, the habitability of the ecosphere is questioned. So, which means that the current human activity is not sustainable. And of course, since it's not sustainable, making it grow is even less sustainable. And making it grow exponentially, it's even less and less sustainable. So there is another scenario that you hear about, which is green growth or sustainable development or whatever. And I want to emphasize that, yeah.
I have a question on the previous slide,
Yeah.
clarification. When you say current society is not sustainable, is it a fact or an opinion?
Okay.
And if it's a fact, on what?
Okay. It's a fact, a clear fact regarding matter, because the current rate of consumption of matter means, as I tell you, that 80% of the materials are critical within typically 50 years, some 30, some 70, but over decades. So if you think, if sustainable for you means over several generations, For matter, that's true. Okay. For climate and other aspects like biodiversity, I do think it's a fact. It's not in my domain of expertise, but I consider that as a fact. Okay. And if something is not sustainable, then the growth of it makes exponential growth of it makes it less stable. Exponential growth means it grows very quickly. Okay. Does it answer the question? Okay. Major green growth. In the strict sense of green growth, the promises are that you can pursue economic growth, but and profit, but you decrease the overall consumption of energy and matter. And simultaneously, you decrease the overall environmental impact. And in some definitions, green growth should include also positive social impact. Well, this definition of green growth or the sustainable development is not realistic at all. For the scientist's point of view, factually, I can tell you there is no experimental example of that and no theoretical proof of the feasibility of that. So that's a fact. Now, my opinion is that it's absolutely not more realistic than the perpetual motion machine, which we have stopped considering since the 18th century. It was very popular at the time. So this is maybe you know this shadowing where the water is continuously flowing, and you extract energy thanks to the mill. Okay, that's when I hear people talking about 100% recycling of textile and plastic. For me, 100% recycling means the same. Of course, recycling, even if we could recycle 50% of plastic, we will use a lot of energy and of chemicals to do that. And 100% is just not reachable. So what I claim, and from the physics point of view, is that claiming that we will orient all the policies in that direction is either being naive or ignorant or being a crook. Okay. Now, in fact, there is a minor version also in the public discourse, which is, it's not always clear that there is this distinction, but people are talking about decarbonation. Means that you promise to pursue the economic growth and activity, but decrease the carbon emission of, depending on the version, either you focus on carbon gas or all the greenhouse gas effects, all the greenhouse gases. And so this, we have many politicians which promote decarbonation and many scientists also. And and scientists say it's very important to protect the climate and we shouldn't be climato-sceptic. And so, of course, decarbonation is one of the first steps to address one of the most urgent problems we have, which is climate change. But decarbonation is not sustainable either, because it raises several problems. This graph by Jan Konietzko is they call carbon tunnel vision, which means if you focus only on carbon emissions, you don't look at all at whatever else is near it. The graph is not very visual, but I like it anyway. Okay. So why? I will take a few examples. If you just focus on the energy, because usually people who focus on decarbonation talk more about energy, not only, but more. Energy. Proponents of decarbonation means we can use renewable energy or nuclear energy. Each one has advantages and drawbacks. Renewable means that the source of energy is the sun and can last forever. But the problem that we have is the surface, the competition for the surface. The nuclear energy, this has no problem of surface. It's very compact and very dense energy. But the problem we have is that the uranium, it's like oil, gas, and coal. There's a finite amount, and we are reaching limits for that. We are reaching the soft limits very quickly. Okay, not the hard. The hard limits are very far away, but the soft limits are very close. And whether renewable or nuclear, have the same drawbacks. They require technology with a high power. They require a lot of materials. They produce much waste. And there is a strong rebound effect. That is, if you care about producing more energy, you will have more action on the world. And you will not decrease the action. You transfer fossils maybe to to renewable, or you would just add them, combine them. But anyway, you will have rebound. As long as you have energy available, you have rebound effect. That is, the energy will be used. So another scenario is degrowth. And degrowth is defined very qualitatively, globally. It's not an economic view like a growth. And so there are several definitions. Here's the one I use. Degrowth means massively reduce human activities in terms of size, of power, of speed, of consumption, and consumption rate. And also, in order to make it acceptable, reduce inequalities, whether social, geographical, environmental. Which means that this is possible only, in my opinion, only if you have a balanced actions on several sectors: economics, culture, politics, offer, demand. Because if you have a system which is equilibrated and you cut only one, for instance, if you decide you cut the energy sources, but you don't make any cultural effort or any political effort or any effort on the demand, well, if you cut only one pillar, everything will break down probably. While if you decrease everything, you have a better chance to keep a system which is balanced. In my opinion, degrowth is not only necessary, but also desirable, and that's something we can discuss. And desirable not only for the poorest part of the humankind, but also for the richest one. It faces a lot of difficult human obstacles. The main real one, is that if degrowth is done in a part of the society, it's subject to predation from the parts of the society which do not degrow, whether by economic competition, military competition, or whatever. There is the problem of competition which has to be addressed. In fact, I just want to emphasize that there is a difference, qualitative difference between human obstacles and physical obstacles. Questions on that part? Yes.
Maybe it's more related to the previous part, but
no problem.
You presented, it's a bit a provocative question, but it's to better understand your line of reasoning. So you presented the carbon as the end product of the matter, and so the accumulation problem. But if you would have done this presentation back when you were not able to use oil, you could have presented oil as the end product of matter degradation. And so this is all about this soft limit conception. Back then it was a soft limit to be able to use oil. So I was wondering, how do you account for the fact that those soft limits, they are not fixed, they can move over time? And do we know at what rate do they evolve?
Yes, we can go back, look at the soft limits in the past and extrapolate them. Maybe I go in more detail in the debate, but just for clarification. For a long time, people said, well, if some material is critical, we'll turn to another one. That's why I stress the fact that when you are at the point where 80% of the table becomes critical, this line of reasoning becomes difficult. Okay. But still, I'm talking about soft limits. And I will give an example of clarification, uranium. I said soft limits and hard limits are very different. That means that soft limit can evolve a lot. Because why? There is uranium which is accessible typically in 3 countries in the world, easily accessible, and this will from the proven reserves, it will come to the end within a few decades. We don't know all the reserves the resources in uranium in the ground, but they will become more and more difficult to find and to extract. And that's difficult to predict. What we can see is that already there is a huge amount of uranium in the ocean sea, in the ocean water. And some people have prototypes to extract uranium from seawater. But what you can look at is that the orders of magnitude means that to harvest this uranium, you need a lot of energy, a lot of plastic, and you will release a lot of plastic in the ocean. So, of course, this soft limit, you can evaluate it, and then you fall on the environmental limits very quickly. Okay. So this is why I say it's a very coupled system. So some questions about self-limits are difficult to answer, some are easy to answer. Okay. And then I will be very happy to discuss that more. Yeah.
Another question, the difference between the minor and the major claims of green growth.
Yeah. Okay, clarification.
Between minor and major.
Okay, minor means decrease carbon. You go on with profit growth, but you decrease the carbon emissions. Major growth means you go on with profit, but you decrease all the problems: energy consumption, matter consumption, environmental impact, that is plastic pollution, acidification, climate change, all.
So the scope of the problems that are targeted.
Yeah, and I would say that the measure of green growth would be useful in principle. It's just infeasible. The decarbonation might be possible at the expense of many problems, but it's useless. And and that's an opinion. One of my opinions is that the confusion between total major green growth and soft version, minor version like decarbonation, this confusion is done on purpose in order to make you think that it's both feasible and useful. But that's an opinion. Yes, just clarification questions. Yeah.
So the only difference between major green growth and degrowth is the economic growth.
Yes.
In one case,
yes, but it's the paradigm. One starts from the fact that we want to pursue growth and then to keep current material consumption, and we try to adapt the limits to it. When the green growth, the degrowth starts from the fact that there are limits and that we want to respect all of them, and then we completely change the system if needed to adapt to it. So one will make a complete change of the system, and not one is close to business, non-business. But you are right, there is a common point. Yeah. Yes.
How efficient can be recycling?
This is depends on the definition you have. Currently, metals are, and especially like aluminium and some others, are very well recycled, especially when they are used in not diluted applications. If you former cars, which where there was a lot of pure steels, were easy to recycle. Current cars are much harder to recycle. The plastics, it's a catastrophe. All the rare earth, so-called rare earth elements which are used in electronics, is the catastrophe. Paper can be, it's one of the best, with metals, it was one of the best intelligent things to recycle. Glass is at the limit. Producing glass and recycling glass uses about the same amount of energy. Okay. Of course, reusing glass is cool because glass can be washed, but if you melting sand or melting used glass to produce the glass, it's almost at the same temperature, so you almost use the same amount of energy, which is the most costly part of the glass. It's not the material. So the answer to your question varies. But when I hear textile 100% as an objective, I just joke. It's just, and of course, many recyclers, for instance, batteries. One of the big questions is batteries. Some phones or cars have batteries which are soldered so that they cannot be recycled at all. But even the batteries that can be recycled means a lot of chemical products, so a lot of energy, but also much chemical products to recycle the parts you want to recycle. So you consume more matter to recycle what you want to get. Yes, there was a question?
Yeah, so on the graph with your carbon tunnel vision, right, that suggests that all of these points are equally important, whatever importance is.
You can call them important or not. That's not, it's just that they are not seen.
So that was my question. If you were weighting these with a priority or with a amount of problems that causes, would you still have the same very narrow focus?
First, weighing priorities is political, so it's an opinion. And we can have all different opinions on that risk.
But you can weight that with impact on matter and on energy, for instance.
Okay. The one eutrophication water crisis, these are the environmental limits. Resource scarcity is the soft limits. Overconsumption is about the same. Air pollutants is ecotoxicity is environmental limits. Biodiversity loss too. And inequality, health, education, poverty, that's social and socio-economic and politics. Does it answer your question?
To stop to do any weighting.
Well, again, weight is your own opinion. Your opinion and mine will differ on that.
So my question was whether there's an objective way of, it's a fact question, right? Because intuitively, you might put different priorities to these problems.
Again, let's keep that for the debate. I think that giving weight and importance to some aspect with respect to others is a matter of opinion and then of choice. And choosing between the scenarios I presented, you understand that there is one I favor with respect to the others, but that's a matter of opinion. Okay. Yes? No, but okay. I think now it's better to go on. Okay. Now research, a bit a word on research in that context. Okay. Here research means in very broad sense discovery or invention that is applied or fundamental and that is new knowledge or new possibility of action. It's any disciplines, whether human science, experimental sciences, academic or industrial, civil or military, public, private, whatever, all that global ecosystem that we all know as research. There are many personal positive impacts of research, and I could speak about them for 2 hours if you want, but I don't think it's useful. They are multifactorial, personal, cultural, social, material, whatever. There are many positive impacts of research. But and everything which is important but is not important. There are many negative impacts, and the one we talk about more and more in the hard science community, and I think probably in your community too, is the direct negative impact that the research activity has on resources and environment. And that is what our daily activities of research, transport, missions, technologies, large-scale experiments, which is more for physicists than for ecology, of course. And all that is discussed in the frame, for instance, of Labo 1.5 and on other collectives. Some of them are very active in Montpellier. So many people would say that research is very important to provide alerts. And the example which is often given is the IPCC, which has one advantage, make a great collective effort across the planet to focus on the climate change problem, which is a complex problem, which is urgent. And so it's advocated that research is very important for them. The two drawbacks, first, the focus on climate, which is part of the green growth discourse, and especially the IPCC focuses on that. Although in the 6th report, second working group, there were allusions to the and advocacy for the growth, but it was in the groups of physicists, and it was not reflected in the group of economics or in the political decisions. So, well, in my opinion, and that's really opinion, what are the problems to have too much faith in research? First, humankind is not destroying the planet, the habitability of the planet, just because we are ignorant. The motives are more struggle for power and profit. And it's not also because we lack techniques. And what we observe very often is that people who claim that that the solution is research, so very often it's a way to delay the action. It has been done in several questions related with health, also with global problems like the habitability of the planet. What I think also, again, it's an opinion, I think the most problematic impact of research is never or very seldom discussed, it's not the direct impact of our activities, it's the indirect impact. What does it mean? Research has to produce novelty. That's our job. Here I'm talking about all disciplines. And research is a pillar of economic growth. And for instance, that's really what our funders tell us. And it was very explicit in the President Macron discourse on research, saying we rely on you for economic growth. That was explicit and clear. And in fact, growth and research fuel each other. There is a positive feedback, not only because materially growth feeds research and research provides the products for offer, which fuel growth. It's one of the things which drives growth, not the only one, of course, but one of the drivers. And also culturally, the ideology of growth is in favor of the notion of progress in research, and vice versa, the notion of progress of research favors the idea of growth. And that's one of the reasons for the fact that the growth is exponential is because there is this feedback with research. More growth means more research and then more possibilities of action. Hence the exponential. What are the reactions of many scientists? The majority of people I talk with can be split in two classes. Those who want to accelerate and who ask for more money, what I call the headlong rush, calling for decarbonation, sustainable development fueled by research. And I like the comparison with the cartoons of Charles Jones. Well, you go on running even if you have the ground under your feet. And another part of the community, and I am more in the second part, so I consider myself in that, tries to protect one's self-esteem in a way or another, saying, okay, by a variety of denial mechanisms, trying to say what I do is not the worst. And what they do is bad, but what I do is okay. And if possible, if I can protect my funding, that's even better. Well, in fact, there are more and more recent polls, these are in the last 3 years in the community, which shows a change in the perception in the academic community, in different disciplines across the world. It corresponds to my own experience. Since 2018, I've seen a change and it grows. Here, in some of the polls, it's between 20 and 40% of the academic persons which have been polled, depending on the way the questions have been posed or whatever. But up to 40% of people who think that degrowth is a solution. And what is interesting is that the faith in green growth has dropped correspondingly, and the curves are crossing each other now. We are about at the time while in 2018, when I began this kind of discussions, there was no question. Nobody was thinking about degrowth at all. So there is a change, in fact. And so what could we do as researchers? I would say, again, we are in the opinion, not in the fact. I think, well, we can improve our research direction method, especially by decreasing the competition, I think. And also, of course, people told me, yeah, but are there researchers that you could stop in priority? Yeah, well, I would say yes. You could identify things that with various criteria, you would say this research should be stopped. I would say, for instance, in physics, the CERN, the upgrade of the nuclear accelerator research for in Geneva, or the ITER, the look for fusion, or in ecology, more the geoengineering, and also virology, the gain of function research in virology. These researchers could be stopped for very good reasons. But more important, and I want to stress that it's much more important, that we have to think, exert our critical mind, because we are supposed to have a critical mind, so we are supposed to use it, and think very globally in terms of energy, matter, environment, and so really find the basis of the problem, which is the will to power. And that's very deeply rooted in the human psychology, and the will to power is what fuels the growth. And so we have to accept the limits, And then that means that we have to accept to work below solar flux, below to work with within matter stocks, and to work limits of the physics. Questions on that part?
Question, maybe it's more for the debates.
I will tell you, yeah.
Is it the end of the discussion?
No. No, I will have the take-home message first.
Okay. So I have several comments about like the negative indirect impact of research. I think one of the biggest problem I saw is like our faculty to make some political problem objective, to objectify political problem. Like for example, political problem is where there is not a very objective, better solution than one or the other. But the fact that we turn a political question into a scientific question, we tend to produce objective looking question.
Okay, if it's a comment, then we keep it for the debate, okay? Okay, yeah.
Yeah, I have a question online from Kamiko, who is asking, like, did you say stop research in virology, or did I misunderstand?
Gain of function research in virology defined as, GovRock, that is gain of function research of concern in virology. Yes, there have been calls since 2011 for stops for gain of function research of concern virology research to be stopped. There has been a moratorium in the United States from 2014 to 2017. And personally, in my opinion, we should be much more strict and much more long in stopping this kind of research. And even there has been in synthetic biology more broadly, there has been a call by the community itself to stop like mirror xenobiology. So yes, there are specific researchers that I think can be stopped on very objective argumented reasons. Yes. Yes.
Why did you say that we should have a reflexive perspective on our own work that doesn't match the reality of our colleagues? Say the room is almost empty.
The what is
The room is almost empty.
There are 35 persons online. Well, I don't know.
But I mean, like, why would researchers be more prone to, like, this is
Okay, because one of the reason researchers use to defend research, and that I will have animate a workshop on that on Tuesday in Toulouse, is they want to defend research against Trump attacks, for instance, on academic freedom. And one of the main arguments to defend research is that we are the place where we keep alive the critical mind. And then I said, then if we want to justify our own work, then we have to exert it also on ourselves. Yeah.
Another question online, maybe it's more for the debate at the end. But,
yeah.
To what can we do? Act politically. I guess S4F is science for future, scientific rebellion, etc. What is your take on that?
Debate. Clearly debate. So let me finish with the take-home message. So take-home message. I think we really, whatever we do in our work or out of our work, we need to think global in terms of matter, energy, environment. And remember that quantity conserves and quality degrades. Whether green or not, growth is utopic because it faces limits, which are, and the three limits it faces are environmental, economics, and physics. And the environmental are much more urgent and quick than the economics one, and the economics are much more quick than the physics. But of course, these are physics you cannot overcome in principle. I mean, there are no examples in history to overcome them. Those of economics and of course of environmental, you can take decisions regarding them, okay? Degrowth is meant to improve life quality, and it's meant to put life quality and planetability before power and quantity. It means self-restraint on consumptions and a decrease of inequalities, which faces a lot of human obstacles. And what I say, and that's a fact, in the history, there are much more examples of changes, strong or small, quick or slow changes in human systems, whether economic, social, political systems. There are many examples in history of changes by evolution or revolution, while I am not aware of any example in the history of humans violating the principles of thermodynamics. And so I think we have to question our research and to accept limits and to stop the race for power. Here are a few suggestions for further readings. Our articles in Magazine La Décroissance on the conversation, in the website Pièces et Main-d'œuvre. Passerelle, it's a collective I have created with a few colleagues, where we have some teaching videos on degrowth and these comics. Yeah. Thank you very much for your attention.
We don't have a lot of time until 12:30, but we can discuss, and feel free to leave if you have something else to do or bored. No incentive to stay if you don't want to, but like we can have a few questions and maybe continue discussing. Also for early career scientists, we will have a discussion at 2:30 at ISEM at building 22 in the Triolet campus. So
there was this question line.
Yes.
Yes.
What was it?
Robert, you're allowed to talk if you want to ask your question yourself. Okay, so I guess I will re-ask it. The question was about what we can do, act politically, sign for future scientific rebellion and so on. What is your take on that?
Okay, what can we do? My opinion on what we can do. I think there are several things you can do individually, globally, organize yourself or not. That's very personal. I would urge you to keep in mind the real boundary between people who think only in terms of decarbonation and people who think globally. I think the boundary is here. If decarbonation is the first step to really act globally on all aspects, then you are going in the right direction, I think, and you will end up, once you see that major green growth is not possible, you will end up with degrowth. I think more or less automatically. While if you start with decarbonation and say, I will focus on that, very likely you will fall back on a way to preserve growth and preserve the problems. So I think this is a good guide when you go to either you want to have personal action or global action. I think it can be a guideline.
Okay. So you mentioned IPCC, but there is another report, which is IPBS, which was published recently, which actually tells more or less the same thing as you are telling. Basically, their main framework is more or less a summary of what you have been telling. But it's kind of a letter to Santa Claus. So how do you implement all this?
Okay, that's why we did the comics, because in our articles and things, first, it's more theoretical. In the videos, we address a bit the question of practical way to do it and obstacles. But the comics is a way to address really what are the problems when you try to, and what works and what doesn't work when you try to put it in practice. There is no single answer to that, because again, it means political choices to make collectively. So I can have some opinions, I can have some personal choices, like trying to, in my daily life, trying to avoid many things when I can, including the fact that I don't have cell phone, for instance, but that's a personal choice, of course, and several other things. But I would say the driving point is, in my take-home message, accept limits, stop race for power. That's, I think, it's the guideline to implement degrowth. After that, how to do it will go on. But you have to change the foundation, the way we think first. And as I said, not only the way we think, but also production and offer and demand. So that means, for instance, I talked about the negative impact of research, but of course, there are other drivers of growth. One is advertisement. The budget of advertisement in the world is the same as the budget of research. And of course, they have the same importance as fuels to growth. The military budgets, which are 3 times larger and in exponential increase now, larger than research of other advertisement, of course, they are drivers of growth. Okay, so these are the way to act on real structural basis of our current society. But you have also cultural change, political changes, everything needs to be addressed at once. If you don't want to imbalance it. If you just cut energy, if you decided to cut energy immediately, well, that would be problematic. Well, okay, yeah. Although degrowing society is much more resilient to, for instance, problems with electricity network, like we had in Spain and Portugal recently. A degrowing society is much more resilient than the current society.
Particularly also some people would like to say, people who haven't asked questions, feel free, even if you want to ask them in French, I can translate. But yes.
So I agree that the research is like really supports the economy, and at least the way we are doing research now. But I would like that you come back to the slide where
issue of research.
Yeah. So I was wondering, in this list of items, do you think that there is intrinsic, like, I don't know, like, do you think that the production of knowledge intrinsically, like, is a pillar of economic growth, or is the way we produce knowledge, for instance, and we use this for every?
I think it's structural and intrinsic to research. Yes, and that's why I, on purpose, mixed everything. I know how to distinguish, for instance, applied and fundamental research at the stage of the funding and at the stage of the motivation of the persons who do that. Although in most examples that I know, they are mixed both in the funding and the motivations. But once something is published, I don't know at all how to make the difference between applied and fundamental research. And I like to quote examples like if you think that the geometry of the Greek antiquity or the invention of imaginary numbers at the Renaissance time, well, all that was fundamental research with applied objectives, and geometry was very applied, and of course it has consequences both applied and fundamental now, 2,000 years later. So it's so unpredictable. And me, for instance, when I try to avoid military applications, for instance, and I try to do what I thought was fundamental research, and I was very surprised several times, at least 3 times, to see that the first persons, or sometimes the only one who came to see me to discuss on my work were militaries. Yeah. Yeah. Can we take it?
Yes. Julia, your mic is open. Okay.
No.
Ask the question?
Yeah, I guess I read it. Then we have.
Can you read it?
Yes. Are there any reasonable evaluations of effect of regrowth? Any assumption made on how feasible is to prevent climate crisis with, let's say, only regrowth and not developing technologies, or combining regrowth and developing green technologies? Of course, all such evaluations have limitations and should be seen critically, but still, are there some that you trust and can recommend?
Okay. Evaluation of degrowth, huh? You said regrowth?
Yeah, but I guess it's degrowth.
It's degrowth. I am degrowth. Well, first, there are a few things regarding energy, matter, carbon, feasibility. This question is very multifactorial. Yes, there have been evaluations of how much we should reduce And in fact, at least we should reduce a huge factor, but we have grown a huge factor in a few generations, typically since my birth. And if we were at the level of consumption of energy and matter that we had at my birth, already it would be much more sustainable, really. So it's not like it's always said, coming back to Neolithic. Of course, this heavily relies on the demography, and so on demographic projections too, and that's a very wide field. But demography, it's not, unlike people think, reducing the demography does not necessarily involve unpleasant things like war and genocide, which are very, not only unpleasant, but also very inefficient and very costly. There are many more pleasant ways to reduce demography, like educating young women, like diffusing contraception, like diffusing retirement systems, and several political ways to act on demography. Well, another part of the question, yeah, are there evaluations? It's difficult to evaluate, especially since there are many possible ways to implement degrowth. And does it rely on life-inspired technology? Yes, that in fact, whether we stay with traditional technology or we develop new technologies, all that have to respect, to be sustainable, have to respect the solar flux and the law and avoid concentrating materials. And so that means that life has been doing that for 1 billion years with more or less success, but that is its source of inspiration. And yes, not only traditional human activities, but also traditional living activities can be sources of inspirations.
Yes, maybe a last question.
Does it make sense to say that research in general fuels growth when you have like research disciplines like humanities or maybe literature research and even ecology on one side, and other fields like in the research in industry, which specifically aims at developing new chemistry methods?
I have this question at the end of each of my conference. So thanks for having asked it. With only one variation, is that each time the person who asks the question includes his or her own field in that. So yeah, so you have included ecology. I assume you are in ecology. Yeah, but sometimes people ask me with geography. You said human sciences. I have geography or anthropology, whatever. I'm really happy to answer that, for instance, geography is entirely, the development of geography has been entirely linked with colonialism, imperialism, mining, and military. It has been in many countries, it's the property of the army, the maps. The anthropology has been entirely related with colonialism, biological racism, and genocides. I have several examples of sociology. I have many interesting examples of sociology. So what I say is there can be niches where you avoid. I've tried to do that for myself and failed. At least for me, I can tell you I have failed. So maybe some of you in the room can, but structurally, the system in all disciplines considered now fuels not only capitalism, but more generally the race for power. It's much before capitalism. I don't know when you did the beginning of capitalism, but research has been fueling the search for power for centuries and thousands of years. So what I say, there is the question, should we stop scientific research or not? The question that has been very popular for 1 century and popularized by Grothendieck in 71, 72. I don't know. What I say is that we should, before asking this question, we should first change the paradigm and go in a degrowing direction. You found the foundation of a house before you ask how you decorate it. So before asking what we need for defense or police or research or teaching or health, we need first to have a degrowing framework of thinking, and then I will be happy to discuss what we should keep in research.
But isn't it a risk that if you need to change, you were talking about suppressing some fields of research, for example.
isn't it possible to argue that some research in humanities, which clearly are built on things from colonialism and don't produce something directly, wouldn't it be more easy to say, let's suppress this field because it takes resources and it doesn't produce something
Well,
useful?
well, all research produces something useful. I mean, that's not, you cannot know. It's so unpredictable. And I wouldn't say that you should suppress geography because geography doesn't produce anything useful. The question is not there. I would say some people ask me, yes, but you don't change the system immediately. So what should we do in the immediate? I can have some partial answers and saying some things are blatantly problematic with very objective respect. But more generally, if you just think in that respect, you just change the symptom, but you don't act on the cause. So I really urge you to think globally. Do we stop there?
Yes, I do think we stop there.
Okay.
Thank you again. So there's François still around for the day, so maybe if you want to test some arts in particular.